Next question is question number 29. Okay, so what we have here is 3 pieces of timber, which is a wood, 42 meter, 49 meter and 63 meter long, have to be divided into planks of the same length. So we have 3 pieces which we have to divide. We have 3 pieces of different length and we have to divide them into plank of same length. Then what is the greatest possible length of each plank? So since we have to divide them into the same length and that to the greatest possible length, that means we have to find the HCF here. And the 3 numbers are HCF of 42, 49 and 63. And we know, kids, how we have to do this. First of all, we will pick these 2 numbers. So we have 42 and 49. We'll have 1 here. 9 minus 2 is 7. With 42, it is 6. Straight. Right? So the HCF of 42 and 49 is 7. I'm writing here HCF of 42 and 49 is 7 because it is giving us the remainder as 0. Now next what we will do? We will find the HCF of 7 and the remaining number, which is 63. And we know that it is a direct multiple. This is 7 into 9 is 63, which will give us a remainder of 0. That means the HCF is 7 only, right? This 7 is the HCF because it is giving, this is the divisor which is giving us the remainder as 0. So the answer here is 7 meter. That is, each plank has to be divided into 7 meter. The greatest possible length is 7 meters here. Next question. 3 different containers contain 403 liter, 434 liter and 465 liter of milk. Now, find the capacity of a container which can measure the milk of all the container in the exact number of times. So, again, what we have to do is we have to find their common factor, which is the greatest common factor. So, this I am leaving as a homework, kids. You have to find the HCF of these 3 numbers, right? Next, what we have is there are 527 apples, 646 pears and 748 oranges, and they are to be arranged in heaps containing the same number of fruits. Find the greatest number of fruit possible in each heap and how many heaps are formed. So let's pick this question. What we have to do here is we are given with 3 different type of fruits and their quantities, and we have to find their heap. We have to form their heaps like this. Okay, we have to arrange them in the form of a heap. One heap for, no, we don't know the number of heap, so we want to make the heap for apples. Similarly, we won't have to make the heap for pears and for oranges as well. Now what we have to do is these heaps, they should contain equal number of fruits. That is, the quantity of apples in the apple heap should be same as the quantity of peaches in pear heap and the oranges heap. So what we have to find is their greatest common factor, because what we need is the greatest number of fruits possible. This is the one part of the question. So let us pick this part first and let's try to solve it. We have 527 apples. I'm writing 527 apples. Then we have 646 pears and 748 oranges, right? So what we need to do is we have to find their HCF first. I'm picking these 2 numbers. I'm finding their HCF. 646 inside, 527, 1 here, 527. Now 16 minus 7 will give us 9. And then 3 minus 2 will give us 1. 6 minus 5 is 1 again. And then the second step. Okay, so now let us try to do this with 5. 119 into 5, 9 is 45. 5 plus 5 into 1 is 5 plus 4 is 9 and 5, 95, which is little greater. So let's move for 4 into 9 is 36. 4 into 1 is 4 plus 3 is 7 and 4. So 119 into 4 will give us 476. This is 1. This is 5 here, 51. And now let's do this with 9. Let's try to check with 9. Sorry. So we have 51 here and we will take 2. 102. 9 minus 2 is 7. 1 as is and 51. This is 3 direct multiple. And then what we have here is HCF as 17. The HCF of first two number is 17, but we have one more number, oranges. So we will take HCF of this 17 and the number which is remaining, 748. Okay, so what we will do here is we can take 17 and 74. So 17 into 4, 68. 14 minus 8 will give us 6 and then 68 again. This is 44, which is exact multiple. So that means what we have here is 17 as the HCF, right? So we have 17 as the HCF. That means the greatest number of fruits. The greatest number of fruit possible in each heap is 17. Okay. And now what we have to do is how many heaps are formed. So kids, how we are going to check that how many heaps are formed? So for apples, what we will do, we will take the total number of apples, divide it with the HCF. Okay. Similarly, for the other fruit, which is pears, 646 by 17. And for oranges, what we have is 748 divided by 17. So dividing this, we will get the answers of how many heaps are possible here in each case. So we can divide and check. We have 527 with 17 into 3 is 51. 2 minus 1 is 1. So this is number of apple heaps are 21. Now we have pears. So for pears we have 646 divided by 17, right? It is, this one is again 3. So 51, 4 minus 1 is 3, 6 minus 1 is 5 is 1 and this is 36. So 17, 8, 7, 56, correct. So we have 38 here. And then the last one, that is 748. So for 748, we will divide this by 17. 748 into 17. So we will have 4 here and again we will have 4 here, right? So we have 44 oranges. These are the different heaps of fruits. Okay, so this is done. Next what we have is determine the longest tape which can be used to measure exactly the length 7 meter, 3 meter, 85 centimeter and 12 meter, 95 centimeter. So kids, first of all, the dimensions, they are different. So what we have to do is we have to change everything into one particular unit. Okay. So we have meters and centimeters. Now the question is whether we should convert them into meters or centimeter. So kids, if we will convert them into meters, we will get the answers in decimals and it will be little hard to find out their HCF using the decimals. So what we are going to do here is we are going to convert them into centimeters. So the first number will become 700 centimeter. This number will become 385 centimeter and the third number will become 1295 centimeter. And then what we have to do is we have to find the longest tape which can measure them exactly. That is, we have to find their common factor. So we have three numbers and you have to find their common factor. So this is easy and I am leaving this as a homework. Next, we have a rectangular courtyard is 18 meter 72 centimeter long and 13 meter 20 centimeter broad. These are the dimensions of a rectangular courtyard. Now, it has to be paved with square tiles of same size. Now, we have to put square tiles of same size there, okay, in both the dimensions, in both the length and the breadth size. Now find the least number of such tiles. So kids, if we have to find the least number of such tiles, that means the size of the tile should be large, okay, and the size of the tile should be accommodating both the dimensions, that is the length as well as the breadth. Okay, so that means what we have to do, first we have to convert them into one single unit. What I'm doing is I'm not solving this, but I'm giving you the complete hint and I want you all to do this as a homework. So how we have to go about this question is answer 33. Length of the courtyard is 18 meters 72 centimeters. So I'm converting it into centimeters, which will give me 1872 centimeters. And the breadth is 113 meter and 20 centimeter, which is 1320 centimeters. And now what we have to do is, it is to be paved with the square tiles of the same size. So what we have to do, we have to find their HCF. The HCF will give us the maximum length of the tile, which will be there, which can be put in both the length and the breadth, across the length and the breadth. So what we have to do, we have to find the HCF of these two numbers. Once we have got that number, next what we have to do is find the least number of possible tiles. So the number of tiles, how we will get here is, we will divide this rectangular. We know the rectangle, the length and the breadth is given to us. So we have 1872 multiplied by 1320. Okay, so this will give us the area. We have to divide that area with the HCF and we will get the number of tiles required across the length and the breadth. Okay, this is easy. Next, find the HCF of two prime numbers. So kids, we know that if we have two prime numbers, let me do this here. Answer 34. Answer 34, A part. Two prime numbers. I'm taking two prime numbers. I'm taking 2 and 3. They are prime numbers. Find their HCF. Okay. So we know that in two prime numbers, nothing is common except 1. So 3 minus 2 is 1. And then we have to divide this one with 2. We will get 1 as the answer. It will always be 1. This will always be 1. Two co-primes, this we have done it. This will also be 1. Then we have two consecutive numbers. So let's do for consecutive numbers. So for consecutive numbers, let us take two numbers. I'm taking 7 and 8. And let's find out their LCM. We have 7. 8 minus 7 is 1. 1 with again 7 we will do. Okay. So again this will be 1. This will be 1 again. The last one we have 2 and any even number. So I'm taking 2 and 10. 10 is an even number. Now let's try to find out. We have 2 and 5. This is cross. So that means the HCF will be 2 only. So in that case, what we have is HCF is 2. This is done. So kids, we have completed HCF, both the methods, prime factorization and the long division, and the exercise based on this. Okay. And now next what we are going to do is LCM. And then after LCM, we have the properties of HCF and LCM and questions based on that. That we are going to pick in the next class.